Hello, sorry, there were some internet issues. So I hope I am audible to all of you.
Yes, ma'am.
Okay,
Yes, ma'am.
okay, great. Let us start. Today, we'll look from the coding perspective how to do the dependency parsing. So, can anybody tell what dependency parsing is? Please try to interact as much as
If you don't
possible.
mind,
What is
can we
dependency
discuss
parsing?
little bit about?
Sorry, could you please speak a bit loudly? We cannot hear you.
Am I audible now?
Yes, you are audible. Please go ahead.
Can we just get little more deeper understanding of this weighted R graph and MST also finding the next iteration of weights? Finding very difficult to solve the assignment questions. Actually, we can pick something similar questions and can we
Okay.
try to solve?
Okay, but can we take it up if towards the end or maybe in the next lecture? Because today I thought I'll cover that part from the coding perspective. If you remember, last week you had told like if we could cover those concepts of CFG, probabilistic CFG from the coding perspective, right? I think some of you had requested me. So I was trying to cover all of it from the Python coding perspective. If towards the end we have time, we'll definitely do it. Or alternatively, I can provide you the resources from which we can understand this better. Okay?
Yeah, I'm okay. If
Okay.
everybody's okay, fine.
Yes. So let us, shall I begin then in that case? So I was asking, what is dependency parsing? Anybody could give like a little bit idea? What is your understanding regarding the concept? Please feel free to interact. Like whatever is your understanding in broken words, also you could tell. I just want to know the gist. What is dependency parsing? Why do we do the dependency parsing? What does the word dependency means? Anybody?
Dependency actually represents the relation between different words.
Yes. So it is the structural relationship, right? Grammatical structure between the words, right? Let's say whether
Yes.
it is an adjective nominal or a like a pronoun object or like that, right? Preposition object, right? So there are we'll see it from the coding perspective what it is and how we can do it using Python. So is my screen visible to all? Please let me know. And at any point of time you're not understanding it, any snippet of code, please feel free to let me know. Okay. So dependence. Okay. So as I was discussing, dependency parsing is the process to analyze the grammatical structure in a sentence, and we can find out the related words as well as the type of the relationship between them. So what does it mean is, so say I'm writing like this. Just a second. Today is 6. Okay. So say I have like this black car. So can you tell, is black dependent on car or car is dependent on black? What is the main noun here?
Car.
Why car?
Car can exist without a color also.
Yeah. So maybe here you could understand that black helps us to give the more detail about the appearance of the car, right? This is not a primary thing. It can be any color. So here, car, car is not dependent on black. Black is dependent on car, right? So how should I draw the arrow from car to black or black to car?
Car to black.
Black.
Car. All of us are clear with this. This is the main thing here. Okay. So you could call it an adjective nominal. I think nominal is the correct one. Let us see. So, because why adjective? Because it is helping us to describe the property of the car, right? So what we are saying here is it will have one head and a dependent. What is the dependent in this case? In this case, the dependent is black, right? In this case, the dependent is black, and head car is the head. As I was saying, in the dependency parse tree, you will have one head and one dependent. So because car black is depending on car, so black is the dependent and car is the head, because car can exist without this black thing. It can be a red car or a white car. Okay. So what we are saying, it is having one head and the dependent that modifies the head. How the dependent is modifying the head? It is describing some property of it, okay? And it is labeled according to the nature of the dependency between the head and the dependent. And these can be found in the universal dependency relations. Okay. So this is like the standard some tree banks and all of it will be there from which you can find it out, or using these libraries also we can analyze the relationship. So as we were discussing in the very beginning, when we had performed pre-processing, tokenization, lemmatization, stemming, which library we use primarily? Do you remember?
NLTK.
NLTK. So we also, did we use Spacey at some point of time or the other?
Yes.
Yes, I think we did use once for. I showed you how to do the stemming and the lemmatization with NLTK as well as Spacey, right? So similarly, for dependency parsing tree, we can also use two different libraries. First one is Spacey, and then I'll also cover how we can do it using Stanza. Stanza is yet another library. Another third package that you can use to analyze the dependency parse tree relationships is Stanford Core NLP, but that will not take up. We'll see from these two libraries. Okay. So so Spacey is the open source Python library that for natural language processing. There are several functions and classes pre-written in it. You just have to load and use. Okay. So what we do is, say we are using for the English language, we will use this English model, and say you want to use it for French or any other language, so we can modify it here. Okay. As of now we are sticking with English because I think all of us are very well versed with it. So we'll look at this English. However, you can check, there are available for different language, they are available for different languages, French, Spanish, and so on. So we are using this EN Core Web SM. This is the smallest English model that is available in Spacey. Okay. And what we are doing, first of all, we will load it. EN Core Web SM. So I'm importing the library that I want to use, and I'm loading it. Okay. I'm loading which model? English model from the Spacey library, and storing it in the variable NLP. So let us run this cell. Till this point, everything is clear, or we have any doubts? Any confusions? Can you please increase the font or zoom? Okay, sure. Definitely, I can do that. Is it better? I hope. Is it any better than before?
Yes,
Yes,
ma'am.
ma'am, it's better, ma'am.
Okay. So first of all, we have imported the Spacy library, and then because we want to analyze the different sentences in English language, I am loading this model, ENCore WebSM, and storing it in the variable NLP. Okay. Then I will pass a particular sentence to it. The cat chased the mouse, and then we will try to analyze it. Okay. This token, everything we have to do the tokenization, right? In NLP, how do we proceed is with the tokenization. Let us first see what these tokens are. Okay. So let's say what I will do, I will print the token. And what is doc? We can print doc also. Then we will print some star so that you are clear with what is the difference. So doc is simply the sentence that you have loaded in the NLP object. In NLP object, you have loaded what? This English model, right? And then we are just passing it to this NLP object. Let us check what is the data type of NLP here. It should be a function or a class. It is a default class. Clear? Since it is a class, we can pass it this sentence. So now this is the doc. What is the sentence itself? The cat chased the mouse. And token, what is the token? What is a token in NLP?
Individual units
Individual units of what?
of our text
Or paragraph.
Or a
or paragraph.
paragraph, yes. So what will be the tokens? Will it be the words in the sentences, every word separated by some delimiter?
Yes.
What can be the possible delimiters?
Space.
Space.
Space. One here is space, but there can be several others. Say I am writing it like this. Let us see. It should take, but you can check later if we use the delimiter as and, will it be able to analyze, or do we have to write some separate code for it? This is an exercise which you guys can perform and do, है ना? Okay. This is an exercise for you to look into. As of now, token is in every individual word in the sentence separated by a delimiter, here space. And how many tokens are there? So for token, you can take a variable count equals to 0, and every time you're printing the token you can do count plus equals to 1, and at the end you can print count. This will give you the overall number of the tokens that are there. So see, it is also taking this full stop as a token, punctuation symbol. Okay. Do not say that there are just 5 tokens. That's why I have printed the length of the tokens for here for you to analyze. Why it is saying 6 and how will it help in the dependency parsing, we will see soon. Okay. Clear till this point? Why 6 tokens? Any doubts? Good. So then what we are doing, we are printing token dot text. Can you please increase again? Okay. You want me to increase it more?
No, ma'am.
Okay, okay, fine. Okay. So we are doing token dot text and token dot dep underscore. So this will help you to print the dependency parse tree. So let us see. So what is this token dot text? Is your individual word that you encountered, right? And then token dot dep, it is telling you which word is the root or the head, what is dependent on what. Like the is a determiner here, the root will be this word chased. Okay, how it is I will just discuss. And then again it is printing token dot text. So we are saying here if you ask him to explain what is NSUBJ, say we didn't understand. So we can ask Spacey to explain what it is meaning by the particular tag of the dependency that it has given us. So what we will write, Spacey dot explain, and whichever tag we want it to explain. See here, I understood that det stands for determiner, chase is the root of the sentence or the head, and then dobj is what we can ask Spacey to again explain. So let us see. So it is a nominal subject. Okay, cat is the subject, but the root of your sentence will be chased. So also you can ask it to explain. Say we didn't understand what is dobj, so we can ask Spacey to explain what is dobj. So what you will write, Spacey dot explain, and whichever tag you want it to explain inside the round brackets. Okay, so let us see. It is a direct object. So direct object means it is not dependent on anyone. Okay, so also you can, say you are not understanding, you will say, ma'am, here we clearly understood what is the head and what is the dependent, but in the sentence, that is, the cat chased the mouse, how it should be. So it is saying that chased should be the root of the sentence, and chased, who chased whom? Cat chased whom? Mouse, right? So it is saying that cat is the nominal subject and mouse is the direct object. Is it? The mouse. Right? Clear? Is it clear why it is the root? Or you could call it head. So let us see whether we are getting the same dependency parse tree or not. So you can also print it. You can print it. How will you print it? You can use this displacy.render method. Yeah. Let us print it and check. And we will take 2 or 3 more sentences also to understand how it is doing and what. So let us see displacy.render. So displacy is the package that will help you to, display the graph. Okay. So first of all, we need to import it from Spacey library. Since here you got the error, name displacy is not defined. So what I'm going to do, I'm going to import it from the Spacey library. And see here. Is it clear now? This is the direct object. Mouse is being chased, right? And who is chasing the mouse? Cat is chasing. So it is the nominal subject, right? So correct or not? Understood? It is correct only. So it will be like this. The cat chased the mouse. ठीक है? Clear है? Is it clear?
Yes, ma'am.
Yes, ma'am.
This kind of, when you draw it, like maybe you're not clear ki, here how is it depending on what, and see here also for the punctuation it is generating the arrows, like it need not explicitly say, but it came out as one of the tokens, right? So this kind of analysis help us to understand that mouse is the direct object, and this determiner, because this determiner the is dependent on this mouse. Okay, so this is the local head for the right hand side of the sentence, and for this is the local head cat, but the overall head or the root of the sentence is this verb chased. Clear? So Similarly, it says John reads a book in the library. So can you tell me what will be the root here? What will be the nominal subject?
Reads is the verb and John is the subject. Library is the noun.
Let us see. And what will be in? What kind of an object will it be? Any idea?
Conjunction.
Sorry?
Conjunction.
No, it will be a preposition, right? John reads a book in the library. In, above, under, below. Prepositions, right? From, to, where, from, to. If it were where, when, where, and, both, or not only but also, then it will be a conjunction. No? Clear?
Yeah.
Yeah, okay, good. So let us see this. So it says in is the prep. Prep stands for the preposition. And library is the POBJ. What is POBJ? Preposition object. Here, if you see, mouse was the direct object. But in in uh, in after in is library is coming. So it is a preposition object. Understood? So we cannot say the pattern that was applicable on this will directly be applicable on this. It will be applicable, but there will be some changes as well. Okay? I hope it is clear. Also, we can see and say here we are not understanding what POBJ is. Say this tag I didn't know, so I can again ask Spacey to explain me. So what it is saying, that it is the object of the preposition. And as we discussed, displacy is the built-in dependency visualizer, that is called as displacy. Display, and because it is from Spacey, so it is displacy. That will help you to generate the dependency parse graph for the sentences, and you can get the visualization. And say if you're running your code in the Jupyter notebook or Google Colab, as I am doing, so what I have said, I have rendered Jupyter as true in the render function. What is the render function here? This is the render function. And I have said I want the style to be dependency. I want the dependency graph to be printed, right? So I have set the style to, I have given it the initial sentence that I wanted it to analyze. The style is the dependency. I want to generate a dependency parse tree. Parse tree means it will help you to analyze the structure. Okay. And as I'm using Google Colapse, I have set Jupyter as true, and how much distance I want. This you can modify. Okay. And this is nothing but the formatting only. So not this is just a different way to print the string. So need not worry about this. Let us see how it should turn out. See. So okay, oh sorry, we have done it for another sentence. Wait. Let me do it for John reads a book in the library. Then we will come to this third sentence. So John reads a book in the library. Okay, here we will do it. Clear? This you see, just a second. Control minus. Yeah. So this you see, John reads a book in the library. So reads, what is the root here? Can anybody tell what is the root?
Reads is the root.
Yeah, correct only. So reads is the root, but this library was where he is reading, where, which place? In the library. So in is the preposition, that's why library turns out to be the preposition object. And determiner the is dependent on this library, determiner a is dependent on book, so arrow from book to a. And what he is reading, what is the direct object? See, even if this snippet was not there in the library, this would have been fine. So the direct object is the book here and not the library. Okay. Clear? Dear all, is it clear or not? So, since there are no doubts, I'm assuming it is clear. And I can see some thumbs up. Good. So, similarly, you can do it for this sentence also. Deemed universities charge use fees. Can anybody tell me, like, what will be the direct object? Will there be any adjectives in this or not? What is the root and what is the subject here? Please think for a little while and tell. So, what will be used? What will be the token for use? Will it be an adjective? Will it be a preposition or what? And what is the root and the direct object here? Take a moment to think and please write your answers in the chat box. Then we'll see what does this Python code say. Subject is deemed universities. So deemed universities, both of them will be the subject or only universities? Hmm? One subject should be there. Don't you think deemed is serving like an adjective here? How many of you agree to that? Okay. Anybody else? Okay, let us see what does this say. Let us analyze its dependency parse tree. Okay. I have already run it, I think, in the previous run. Let me run it again. See, what is it? A mod. A mod means adjective modifier. I will ask Spacey to explain me what this. Spacey dot explain a mod. So it will be a mod. Adjectival modifier. So it is an adjective that modifies the meaning of this word universities. Similarly, huge will also be an adjective modifier. The direct object is the fees because charge fees can also be direct. And the nominal subject that is not dependent on anyone else but the verb is the this noun here or the nominal subject. Okay. So part of speech is written here. If you see clearly, this is the part of the speech that is written here at the bottom. But if you are able to analyze what is the head, what is the root subject with the help of these arrows, then it will serve as the dependency parse tree. Understood? And we can also write, like, say who is the head here or the root and what are its corresponding children. So for that, how I can modify the code? I can write str of child for child in token dot children. For whatever word I need the children, I can write it here. Okay. Is it clear now? What is adjective modifier? What is preposition object? So please try to use this displacy.render function. It helps us to draw the visualization very clearly. So I hope is it clear to all? Yes, please. So please tell. Do you have any doubt? I can see you have raised a hand. Please ask your question. Hello. Can you hear me? Is there any doubt, Suvarna? Any doubt here? Okay. So moving ahead, same thing we can do using the Stanza library also. This is a library that was developed by Stanford Core NLP Group, and it provides the neural network pipeline, and it will also help in, like, you can assume that it is an easier alternative to the Stanford Core NLP uh, package. There you need to download the jar files and fire the code on the server. Here you directly install the Stanza package and then perform the required task. So what we are doing here, similar as earlier, first of all we'll
One
install.
second. How are you fetching this documentation for the package and methods?
Sorry,
So,
I didn't understand. Could you please repeat?
you showed the explanation or description about the package and the library, right?
Yeah, yeah. So
Have you that
to
written?
explain, you what I have done here is I have written it using this. So if I use this, I can type some code, right? Right?
Yeah, I got it, but I want to know the content. Did you pull from the Python library any method?
No, no, no. You can refer to the official documentation and,
Uh,
like, or you could, if you know, like, I work a lot on these, so I've written it on my own.
okay, thank you.
Okay. So first of all, we will download the Stanza package using this pip install command. Just it's a safe option to run it always, because if the package is already there, it will display the message like this: requirement already satisfied, and if not, definitely it will get downloaded. So then the next step is, as earlier in the Spacey package we were using nlp.load en core websm, right? That was the smallest English language model that we could possibly use, right? Spacey.load. What we are doing in the case of Stanza, it's an alternative, so just a little walkthrough. So what we are doing here is stanza.download en again here stands for English, and you can modify it for the languages in which it is available. Also you could check stanza supports which languages, and you can get a list of those languages, and then you can do it for that: Russian, English, Bulgarian, scarce. So there are other total 66 languages that it supports. And as for you to know, like, which here it says 80, and I assume since it is the official one, so this is the more correct information. It supports 80 languages as of now. So the audience belongs to which language group here majorly? Can we do for Hindi if all of you are comfortable? Let me see also if it supports or not, because it does support Sindhi and some Asian languages. So if it does support Hindi, I'll show you one example with that. Myanmar Sindhi. See, this is the universal dependencies. As I was talking, this information can be available beforehand. So these are all the languages it supports. See, so it does support Malayalam, some of the major low resource Indic languages. I can see Tamil, Telugu, and what else? Bengali. Does it support Hindi also? Hindi also it supports. So do we want to see in Hindi, or is it fine? You guys can try this on your own, because I think the audience is mixed, so it's better not to go with that and stick to English. However, you can please refer to these three links that I am pasting in the chat box. If you have any specific queries, please feel free to reach out. Okay. So moving ahead, I am still analyzing it for English only. So what we have done, we have downloaded the from Stanza, we have downloaded it for the English language model. And what we are doing, we are using this pipeline function. What does it say? It will help us to initialize the pipeline. And here the first parameter is the language that I want to use. So say I want to use Hindi here. What I can write is, and this, what do you want to write or not, like the prep how do I know that en stands for English, or for Hindi I need to write hi? That information can be available, you just need to check out a little bit. And the first parameter will be the language in which you want to analyze, and the processors, like what all functions I need to use. Say I want to use the parts of the speech, the lemmatization, the dependency parse tree, tokenize. So all of this can be done. What is MWT? What is MWT? Let us see what is MWT in Stanza. Multi-word token expansion. What is that? Add-on modifier. So these are different types of tokenizations that are there. So multi-word is like, if okay, I understood. So let's say we write the sentence like what's up. In general we write like this, right? What's up. So what does it mean? Multi-word token will be what it will split it into what is. Okay, same thing is written here. Multi-word token, it's true Miss Martha. The sentence was this. The sentence they gave was, it's true Miss Martha Jones, hashtag truth. So this it says for the multi-word token. Okay, understood? These are the different types of the tokenizers that you could possibly look into. Okay, so moving forward, so these are all the processors that I want to call, and there are several other processors that are available. And say like every time I want to do the parts of the speech, every time I want to do the dependency parts, do I need to know what is the part of the speech? Is it needed to know the part of the speech every time?
Yes.
Yes. And every time I do the parts of the speech, I need to know what are the different tokens. So we should always use these two together, tokenize and parts of speech. Okay. That's what is written here. For example, pause processor requires, pause is parts of speech. It requires tokenize and MWT, like say multi-word tokenizers. So we need to use these two processors in the pipeline if we want to use the pause processor. Okay. And similarly, as above, we are passing doc is equals to NLP sentence. NLP may we have initialized this pipeline. First parameter is the language and the processors that you want to use together for analyzing the sentence. And all of it is stored in this variable doc. And when we want to print the doc of doc.sentence, let us first run it. Okay, which all we did not run. Okay. So this is super easy package in addition to Spacey. So you can also use it. So we are done loading all the processors. Let us see. Let us first print doc.sentences. Only doc, what is it? Okay. So it is giving me for every sentence. Say the sentence I took was deemed universities charge huge fees. So it has given the word deemed, the ID as one, text is deemed. What is the lemma for it? Is it a verb or what? Is it auxiliary part of the speech? What are the features? What is the head? What is the dependency relation with the head? What is the start and the end character? Deemed university. So how is it writing? Is this? So this overall word it is taking as one ID. These are the IDs. One, two, three, 4, 5. Will it also be given any ID or not? What do you think?
Yes.
Yes. And as for the start and the end character that we were seeing, start character and end character, what did it say for the word deemed? 0 and 6, right? Let us see. Did it say 0 and 6? So yes, it did say 0 and 6. Okay, here it is not giving the ID as 6 to the full stop. It's fine. So it is for the it says the start character for deemed is 0 and end character is 6. So how does it say like that? See. So this is 0, 1, 2, 3, 4, 5. Start character is 0.
Yeah, 0 to 6 is 6 characters.
But end character should be 5, right?
Yeah, if you see the length, it will be 6.
Yeah,
But
length
0
it
to
will be
6
6.
is.
Length will be 6, yes. So I think it is also taking the space into account. Is it? Because if this is 6, then this will be 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. And the end token for universities, end character for universities, it is taking as 19. Yeah, so I think it is taking the corresponding space as a part of that token itself. Okay, this is just a little cat. So, okay, I hope it is clear. Is it clear or not? So, when we are printing, I hope it is clear to all. I am not getting any response. Could you guys please help if it is clear or not? What is pipeline function? Like, say, what we were doing in the case of stanza, if you, spacey, if you remember, we are tokenizing every word in the document, and then we are passing using these processors. But what we do in the space is we initialize the pipeline beforehand. Okay, how do we do that? Like we want to load all the processes that we want to work on this sentence. So for that we have the pipeline function in stanza. That's why we are using this pipeline function. So every library has a unique function that will work in its direction. It's not like if in stanza I'm using pipeline function, same function should be there in spacey. Okay, so in spacey it will work in a different manner, and the processes that you can load for creating the dependency parse trees in stanza would be using the pipeline function. Is it clear now? Is it clear? Okay, great. So how we were analyzing it, it is giving me ID, text, lemma, universal part of the speech, features, head, dependency relations, starting and the ending characters. And Similarly, this thing only is what I have written. It will denote the lemma universal part of the speech. X pause is the tree bank specific part of the speech. What are the morphological features? Text feeds. What is the index of the head position in the sentence? That all it is giving. So but let's say I only want to know the dependency part, so what I am going to use is the doc dot sentences of 0. What is sentences of 0? Let us print and check. Doc dot sentences of 0 is this. Doc dot sentences of 0. Okay, again it is giving me the entire dictionary because we were having here only one sentence, so that's why. And we are going to print the dependencies of the first sentence in the doc object. And what is the format that we are going to get is the token, then index of the head, and what is the nature of the dependency. So let us print the dependencies for this. So what is the token? Token is deemed. What is the relation? A mod, and head is the universities. How did we get in the case of an that if you remember, this was the root. What was the root? Root was this, right? This was the nominal subject, and this was the adjective modifier, a mod, right? And this fees was the direct object. This was a mod. ऐसे ही था ना? Clear है? Was it like this or any different? Guys, I should write a mod here and subject here. ठीक है? So what we are saying here, same thing. Deemed, what is its relation with the head? Head is what here? Universities. But then when the head is charged, then what is the relation with universities? How is the head charge related to universities? Universities is the end subject, it is the dependent, and charge is the head. So at every point of time, we are, if you see what kind of relationship we are taking here, if we are analyzing between these two, 2 gram, but here we are analyzing between these three, so it is 3 gram, 3 at a time we are taking, right? So for here, when charge is the head, the fees acts as the direct object, and when fees is the head, then huge acts as the adjective modifier. Let us see. When fees is the object, charge is the head, so it acts as the direct object, and when fees is the head, huge is the adjective modifier. Root's relationship with itself is the root only. So I hope it is clear now. Is it clear with both spacey as well as stanza how to do?
Yes, ma'am.
Okay. So now moving forward, there were some points that I wanted to discuss last week, but they were left out. So we can take it up. Again, this is showing for week 6. Just a second, open my book. So any doubts so far? Please take a note of these links. They may help you later. So again, using the parts of the speech, how to do the parts of the speech tagging and all we can see. So, oh, I think we had covered it earlier also, but let us see it again. And today we will also cover the ambiguity, how to draw the parse trees, parsing the CFG, probabilistic CFGs. We did the numerical last time. So this all we are going to cover today. So let us start. So what are the two different libraries that I can now use for the parts of the speech tagging? Can anybody tell?
Hessian stanza.
Yes, both of them we can use, right? So say here, let me tell you here itself. Mm, okay. Another one also you could use is the NLTK. एक बार यहीं पे let us try to do it here only once. See, let's just see, as I was saying, whether we will be able to do it or not. So sentence is tag token dot pause. Will it work? Document object is not iterable. Token dot. Mm-mm. But if I am using here, from here also we should be able to get the parts of the speech. So what we are doing here is depth parts we have already called and we are printing the dependencies, right? So say using the stanza library only you want to call. Mm. This is we have so how we can do is first of all we have to do the tokenization that we already know. But for the parts of the speech, what they are doing is word.expose. Okay. First of all, let us print this itself that we can know. Print. So already it is giving me everything as we discussed earlier also. So from here, what I have to pick is the You pause universal parts of the speech or the tree bank specific part of the speech we can pick. So since it is a dictionary, what I can do is print expose. So it is giving me for every is it clear how did I get it, or should I explain? Okay, so first of all we can print the word comma word of expose. I should print word of text only and then word of expose. So deemed acts as the verb noun. Universities is the NNS. So nominal noun subject. Okay. Charge is the verb pronoun. Use is JJ. JJ stands for the adjective here. Right. And then again it is the nominal noun subject. Right. Clear? Because this word was coming out as a dictionary, as we discussed earlier also, that it was having several instances: id, start and the end token, right? What is the lemma, what is the universal part of the speech, and x part of the speech, because we had already loaded these processors. So and when we were doing for the dependency relation, we were accessing this dep rel from this list. See here, we were accessing what? Dep rel from this list. See here, we are accessing the dep rel from the list that specify the dependency relation. But say I want to access only the universal part of the speech, it will be a little different, and you can also access it along with the tree bank specific part of the speech. Clear? So if you are accessing the tree banks universal, it is very clear what acts as the verb, noun, adjective. Clear? Dear all, is it clear using stanza? Okay. So now let us also see how using NLTK. I'll give a quick walkthrough and then we move to CFGs. So we have downloaded the punctuation package. This is the tree bank specific was part of the speech that I want to download from NLTK. Here we are using, we can either use pen tree bank or average perceptron tagger. These are the parts of the speech taggers that you can use, and this is the universal tag set that you can download. And since we want before assigning a part of the speech, you want to tokenize every sentence. That's why we are calling this word underscore tokenize package. And then first of all I will tokenize it, and then I am assigning the parts of the speech to it. So I have wrapped it inside it. So what you could also possibly do is, if you find it a little difficult to understand, what we can possibly do is print. First of all, we just print these word and word tokenize. Let us see what is it. It's simple, but let us see how what are the tokens that are coming out. The exit is an invalid argument. Okay, correct. So these are the different tokens that are coming out, right? And the punctuation also, it is taking as a separate token. Like it was taking earlier the full stop as a separate punctuation symbol as a separate token. Dot it was taking as a separate token, right? So after we have tokenized these words, okay, then what we are doing, we are assigning it the parts of the speech tag. And which part of the speech tag I want to use here? That is universal that I downloaded earlier. The tag set is the universal. And where did we download it? Here only. Clear? And then we are getting it in the
Ma'am,
form of the tuple that,
ma'am, can you please zoom in?
sorry. Yeah, sure.
Thank you.
Yeah. So do you want me to explain it again, or is it clear? Is it clear, or do you want me to explain it again because of the zoom in issue? Okay, fine. So this one we were doing. Okay. So it is displaying in the form of the tuple, like what is the token, what is its corresponding part of the speech. Okay. So now coming to the phrase structure grammar. What is the phrase structure grammar? What does it stand for? Is it another name for CFG or not, if you remember? It's another name for the CFG. So what we are doing is, we do remember what were the rules. What are the rules of the CFG grammar? Can anybody tell? Discussed in detail in the last class, and then we also solved some numericals on it.
Not
What are the rules of the
One, one terminal or two non-terminals on the right-hand side.
one terminal or two? Okay.
Non-terminals on the right-hand side of the rules, production rules.
Was it for CFG or the Chomsky normal form?
Chomsky normal form.
Well, I'm asking for CFG.
Okay.
Please tell anybody. What are the rules for the CFG?
splitting the sentence into phrases and then further into non-terminals and terminals, nominal terminals.
That is fine. That is the definition. I'm asking the rules. CFG grammar rules. What are the conditions on the left hand side, terminals, non terminals, and what is the condition on the right hand side?
And that will become CNF, right?
There were no rules for CFG grammar.
You mean to say that only we can have two non-terminals on the RHS and only a nominal terminal on the RHS?
Mm-hmm. Think a little. Anybody else? Would you like to add something to it? Can you see my screen? Is my screen visible to all? So, what does NP stand here for?
Noun phrase. Noun phrase.
Yes, 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 correct. Just a second, just a second. So, so these are some rules that you can keep in mind for the CFG grammar, where plus sign means that there should be at least one occurrence. Okay, word phrase should have at least one occurrence of either the adjective phrase or the adjective first verb phrase followed by the verb and the noun phrase, or noun phrase and then the adjective phrase. These are some rules that you can keep in mind. So going by this, so if you remember last time we did this example, Peter prefers the flight from Denver, right? How did its dependency parse tree turn out to be? Sorry, dependency parse tree nahi, syntax tree. Can all of us draw it? Peter prefers a flight from Denver. What is the first prerequisite that I need to know? What is the noun here?
Peter.
Denver also. From is the preposition, V is the verb, A is the determiner, and flight is what? Is it acting as a verb or a noun here?
Noun.
What are the rules that were given to us in this? Let us write it here only. Peter prefers a flight. This example we did you all forget it or what? Or was it not clear enough? You did pretty well with me when we were doing in the class. Okay, never mind. Let us see. So, how should we start? Peter prefers a flight from Denver. So, what we want first of all is to begin with the noun phrase, right? So, if I begin with Peter, so since I have assigned it already the nouns and the verbs, so I can write it like noun phrase give me noun phrase followed by some preposition. So is it a valid rule that I should take? Because it is giving me some prepositional phrase. But what I want next is a verb, right? Is it right or not? So this rule is not valid. For the noun phrase, another rule. So what is the another rule that is valid here? Please help. Are you there in the class, all of you?
Yes, ma'am.
Yes, ma'am.
So please help. Which rule should I take? I'm waiting for you to tell.
MP plus VP only.
Just a second. I think this is not the correct set of the rules that should apply to this grammar. Let us open the previous lecture note slides. There we had clearly done this example. So just a second. So NLP. Week 5, right? So if you remember, I had already shared these notes and everything. I hope you have got it already. And here we had done this example. These are the rules for the CFG. Today nobody was able to tell. I was telling you to recall. So alpha goes to beta, where alpha will be a simple non-terminal on the RHS and beta can be any combination of terminals and non-terminals on the right hand side. Simple. All of you were recalling the rules for the CNF grammar. Okay, please take this thing in mind. So next is this rule we did, right? Peter prefers the flight from Denver. This we did, right? Now do you remember? Hello, can you hear me?
Yes, ma'am.
Yes. So is it clear now? We did this set of using this set of the rule we derived this parse tree, है ना? So first of all, what we are doing, we are writing the nouns on the for our reference, and using these rules, then we are trying to derive the parse tree. Similarly, using clear to all how we draw this parse tree, drew this parse tree. We took the rule, sent a start symbol, noun phrase and the verb phrase. Here noun phrase will be, since we want after a noun we want also the verb. And what are the rules that are available with us? Simple noun, determiner, from the noun phrase we can take the noun, and from the verb phrase we can pick up this verb phrase and the noun phrase. From Peter prefers, we will be the verb, and from the noun phrase now you can pick what? This will be the verb phrase, and then what it will come later, then another noun phrase in which you can have the determiner and the noun again. So this rule will go, and after that we want the rule that should give me the preposition and the noun, so you can take this PP rule. Okay, I hope it is clear, or you could recall now. Clear? So if you want to do the same thing using Python code, how will you do it? Is here. We have written this set of the rules. What I am writing, import NLTK package again I am using. I am importing the production and the CFG. So what I am doing is NLTK.CFG. I am using the function from string because I want to derive the set of the production rules here. That is what I have written. The same set of the rules that we used earlier, that S goes to NP, VP, NPN, and for NP there were 3 production rules. Everything that we have written, and this is for the multi-line string. Three three pairs of the opening pair of the commas and 3 pair of the closing set of the commas. This is for the multi-line string. So we have written all the production rules here, and then what I am doing is I'm printing this grammar followed by the new line and the sentence that I want to parse using this C grammar, that is the CFG grammar. Okay, then after I've written this sentence, and that I am writing in the form of the tokens, not in the form of the sentence primarily. I'm already giving it in the form of the tokens, and then I'm calling the chart parser on this C grammar. Chart parser is one of the parsing algorithms that can parse this context free grammar. Okay, and then we are iterating over this tree, and then this using SVG link package you can actually draw the tree and see. So I have printed first of all the grammar with all the production rules that were available, so including these rules, that is S goes to NPVP and all of this. Also the rules were noun phrase or the noun should be Peter or Denver or and the flight, that I had written it like this here with the help of this slash. Here it is taking it as a separate rule. So total there are 11 production rules where the start state is S, and then it gives you the tree like this. And how it is deriving, that is also given. Clear? How to visualize the parse tree generated using the context free grammar and the corresponding production rules. Which parsing algorithm did we use here? Chart parser. Okay. So I'll summarize it again if it felt little difficult to understand. So what we did, from the NLTK package, first of all we imported the production package and the context free grammar. So since I want to give the production rules to it, what I am writing is nltk.cfg from string. This is the predefined thing that you would use to write the production rules, because it will help you to return the grammar instance. Need not remember, you can just Google it out, and also if you're not understanding, if you click on it, it will give you the description. And then this stands for the multi-line comment, and I'm defining all the production rules here. See, here I wrote it like this only with the help of these pipe symbols, but when I'm printing the grammar, it is printing it out as a separate rule. This is one thing that you can take into notice. Then the sentence I'm giving in the form of tokens only, and then I'm using the chart parcel algorithm to iterate over this grammar and print how this tree should look like. And to draw this tree, Like we were drawing the dependency tree in stanza using which tool? What did we use? In Spacie, which tool did we use to visualize the dependency tree? Today we discussed, no?
Display C random.
Display C you
Yes,
used.
sir.
So here what package we are using to draw the parse tree that is generated using the chart parser algorithm is the SVG link package. Okay, this is
Can you
just,
pause null production also here?
sorry,
Can you pause the null production also here?
null production, is it allowed in CFG?
We have seen examples.
Yes, it is allowed. So yeah, what you could possibly write here in that case would be, say, A goes to epsilon, or some symbol you could write. What symbol do we use for epsilon?
This notation is implicit understand, or we can give anything this.
You
I
can give. This will vary on the on the basis of your production rules, right? This is not predefined. I have given it on my own. है ना? So say you want to parse this different sentence that we analyzed. Say this one, John reads a book. That was there, na? Book that flight. So you can now pass this set of the production rules, and you should get this type of the tree. You do want me to do this?
we can try it out.
Okay, just try it. It will be interesting to analyze and see. Also, say now see how we can analyze the ambiguous grammars. So say this is a set of the production rules that is already given to you, है ना? Similarly, we have written the code previously. I'm just trying to explain the concept of ambiguity. So what I am saying, the sentence that I have given to parse is, I shot an elephant in my pajamas. So what do you think is ambiguity here? Do you think it is ambiguous? And if yes, then how did you determine that there is an ambiguity? Or say you take this sentence. Mm, I am just giving you the example of one sentence. The man saw a boy with binoculars. So do you think do you think this sentence is ambiguous? Let us first discuss the concept of ambiguity. The man saw a boy with binoculars. So can there be two parse trees possible for it? So see,
Yes, ma'am.
yes, why? See, here it is not clear whether the man is seeing the boy with the help of binoculars. That is, the binoculars, that is, the man took the help of binoculars to see the boy, or man simply saw man simply saw the boy with his eyes only, but that boy was carrying the binoculars. So it is not clear whether the binoculars were with the man or with the boy, right? So this sentence is ambiguous, right? I can think that the man is saw the boy with the help of the binoculars. Someone else can say no, the binoculars were with the boy and the man saw that boy, right? So similarly, now can you tell whether this sentence is ambiguous or not? This is ambiguous, but why? Can you tell? I shot an elephant in my pajamas. Think
This also is ambiguous, ma'am.
why?
It's like I shot an elephant when I was in the pajama. Pajama refers to the dress, like the act of shooting the elephant first.
Mm-hmm.
And in the other way, it's like I shot a kind of elephant image in my pajamas. In that way, it could be interpreted. So it is ambiguous.
Okay. Sorry, I didn't understand your second interpretation. First one is very clear. Second one is
Maybe short, maybe I think it is like equal to drawing or something. I
Mm-hmm.
have depicted that elephant in my pajamas, like that elephant picture in the pajamas.
Exactly.
That could be.
So here shot is not clear whether you shot it with the help of the gun or with the camera or something. Or as you said, like it could be an image of the elephant was there in the pajamas and you simply shot it or you drew it, right? Uh,
Yes,
do
yes.
all of you agree with that, or does anyone have a different interpretation? I mean, it's quite possible, but do we have any other viewpoints on this? Please unmute and discuss. Anybody else is having a different viewpoint? How many of you agree to what your friend just said? Please raise your hands. Okay, great. See, I see all of your friends are supporting you. So I hope all of you understood it. Now let us see whether the code also says the same thing or not. We are we have written this set of the production rules, and now we are giving it to the computer to analyze. So let us see. So what it is saying, I shot an elephant in my pajamas. So a noun phrase, I is the noun, shot is the verb here. Determiner is an elephant, and verb like the different set of the rules that it is deriving. So when there are two different parse trees possible, like you can derive the same set of the sentence using two different trees, then it is ambiguous. Do you want me to do it with a hands-on example, or you understood? Did you all of you understand why these two different possible trees came out? Please refer to the production rules that are given. Or do you want me to do? Please let me know. I'm waiting for your response. Is it clear, or do you want me to do hands-on with this? So assuming that it is clear, because I can see lots of hands up, thumbs up coming up. Let's move to the next part. So how we can parse this? This we did parsing the CFG already done. Now we will see the probabilistic context-free grammar example. That day we were saying na, that every set of the production rule can have a specific probability associated to it, right? And let us see this example first of all. Yeah, see. So this is one simple example for the probabilistic context-free grammar. What we are doing, we are using the same thing. Now we are not using that CFG package, right? What we are using is the specific PCFG package. Here earlier we used nltk.cfg.fromString to analyze the context-free grammar. But now when we want to analyze the probabilistic context-free grammar, that CFG we replace with the PCFG. Everything remains else remains the same. How does it remain the same? The production rules remain the same, but what you have done is you have defined a probability for every production rules in the square brackets in front of that rule itself. And see, because it was taking it as two separate rules, right? So this should be broken down as, if you do remember what we just discussed, it should be broken down like this. So it will not take as a pipe symbol, but it will break it down. How? It will say that this is VP goes to VP PP, and See, the overall probability, the sum of the probability for any rule should sum up to 1. So for VP, we are having two rules. VP goes to VNP with the probability of 0.7. But also VP goes to VPPP with the probability 0.3. And if you sum up all the possibilities of the production rules for the non-terminal VP, it sums up to 1, right? Is it clear? Dear all, is it clear? Similarly, let us see for NP, is it valid? NP goes to ears, NP goes to saw, NP goes to stars, NP goes to telescopes. Okay. Now let us sum it up. So for NP, just sum it up. 0.4 plus 0.1, 0.5 plus 0.18, 0.68 plus 0.04. What it will be? 0.68 plus 0.04, 0.72.
0.72.
Then plus 0.18, 0.90 plus 0.1, 1.
1.
Clear? So now again, similar example came. What we are saying is astronomers saw stars with ears. So it is not clear whether the stars were having the ears, or astronomers they saw the stars with the help of their ears. Though it is not meaningfully correct, but the sentence is like that. So what are all the different probabilistic like what are the different probabilities of every rule? So you remember we did that matrix kind of a thing earlier. Do you remember we took this matrix kind of a thing to draw
Yes, ma'am.
the
Yes.
PCFG? See here, we did this kind of the probabilistic CKY this thing. Can you try this example right now and see if it comes out in the same way? This is the set of the rules. Can all of you try? Because I think it was not it was covered, but I didn't give you any example to do your practice. Can you try it now, all of you? uh, will all of you try? Okay, please try, then we discuss it in 2 to 3 minutes. I'll open the set of the rules, and the sentence is astronomers saw stars with ears, and then this is the set of the production rules. Please all of you try for 5 minutes, and then meanwhile I'll just a second. Okay, all of you please try it for 2 to 3 minutes and see if these two
Madam, please
answers.
zoom in.
Sorry.
We can't see it clearly.
Okay, I'll zoom it in a bit. I wanted all of the rules should come out, but let me know when you have taken a note of the previous rules so that I can show you the further set of it. So, just a second. Some of you wanted me to go learning phase of MST. Okay, let us see if I can cover it in the remaining time. Please all of you try this is very important concept, and definitely there will be paragraph type of the questions from the PCFG part in your exam. The sentence is astronomers saw stars with ears. Have you taken a note? Shall I scroll? Please try, all of you. Madam, could you please explain the parsing?
Can you paste on the chart once?
Sorry?
Can you paste the grammar in the chat?
Yeah, that will be better. That is a better option. Yeah, please, definitely, I will do that. Arc-eagle parsing. Okay, I will see if I can do that. Meanwhile, you please try this. I will see what examples we can cover. So, just let me know if you want me to cover a specific topic. You can definitely send a mail to me by Saturday or Sunday of that particular week on this email ID, and I will see like if there is a majority request for a particular topic, I can take it up in the tutorial. In the next tutorial, I will cover arc-eagle parsing with example, and then this somebody requested me for the MST dependency parsing. But then if you do have some specific requests, do let me know by maximum Sunday morning, so that I can, kind of prepare accordingly, and we can have a discussion in that direction. Okay? I'll be more than happy to entertain requests on particular topics. Definitely, I will do this. Like you said in the previous lecture, that we can have a hands-on CFG, PCFG. We've taken it up, and then in the next lecture, I can definitely take this up. Let me take a note. Learning phase. Okay, definitely we can do that. Please feel free to let me know if you have requests for certain topics, or you want certain topic to be explained in a detailed manner, so that we can take it up. But before that, please do this example. Already pasted the grammar, and this is your string that you need to parse. Do it with the help of that matrix thing I told you, or any other way you feel is more suitable for you. This topic also, problem based on use this gold standard parse during online. Sorry, Archana, I didn't understand the topic. Problem based on use this gold standard parse during online learning. Could you please unmute and tell?
Yes, ma'am. It's actually a problem based on the transition-based passing learning method. So in that we have a problem where the initial weight is given,
Acha.
and initial weight is given, and we have to find the optimal transition. Just a minute.
Yes. If you do have a specific question, can you show me, like, or is it there in the assignment that you are not able to solve?
Yeah, actually, a sample problem is given in the. Sir has been explained, but I didn't understand much.
Okay. No issue. No issue. So could you
Thing,
just
it is there in the assignment. Anyways,
Uh,
gets
in
definitely.
assignment also we have.
which a second, just a second. Let me open the assignment, and you could tell me the problem number.
7 and 8.
Just a second. Let me log in. So next time, please, I will be more than happy that you could, tell me if there are some specific requests in advance.
Uh,
Yeah. So assignment 6, right?
yeah, yes, ma'am.
Yes. Problem 5 and 6.
Last one. Last.
Last one.
Yeah, this one. Yeah.
The other T is covered it or not?
No, no, ma'am. They didn't get enough time to cover this topic.
Okay, okay, okay. I can take it up. Well, I hope it will be fine by the next week, right?
If just briefly, if we can discuss now, we will try to solve for the assignment problem.
Yeah, at least the problem which is given in the
Weight
slide. Can
calculation.
you
We can take a
explain?
similar problem if you have also that weight
Yeah.
calculation is the
I
confusion.
can just a second. Give me a minute. I think I already have a tutorial on this. Please try to solve this problem I have given. Meanwhile, I'll see if I have already have solved some problem and provide you a solution. Okay?
Yeah, yeah,
Yeah.
sure.
N1 and N3 to N2, and this is having the weight do not get a cycle between them. I will link the two. Or this is fine.
3 H's is needed.
Yeah. So put it like this. Let's say the root is there, Einstein is there, and PV is this node. So in case I have 3 nodes, how many edges should I have so that I do not get a cycle again?
2.
Okay, great. So now, whenever I am creating this new node, combined node, what I will do in this case, this part of the graph. So root to plate to violin, if I take, that would be B3 and F10. That would be in. What is Archana? No, I didn't speak anything, Lokesh. I was just trying to locate the video. So, if you can open this link of the YouTube video that I have just shared in the chat box,
Yeah, it's opening, ma'am.
it's opening, right? So, here
Yeah.
I have already covered some related problems related to the MST dependency parsing. Okay. So you
Okay,
could
okay.
please refer to this, and definitely in the next week I can, since this lecture is already about to get over, in the next week I can definitely take one example from all the 3 topics that you guys have listed. Okay. MST
Oh,
dependency with weights, arc-eager parsing, and then this something gold something parsing that you told, na? Gold standard parse.
yeah, yeah.
So for the like, I would encourage, like, if you could just watch a little of this video that I have shared, so you just have a
Yeah,
little more clarity that when I'm discussing in the next week. Okay.
sure, sure, sure.
Yeah,
Okay, ma'am.
I had already taken this course in the previous run, so I think July 2022. So maybe some of these videos can help. Okay.
Yeah,
And
sure,
yeah, we
ma'am.
are going to cover it. No worries about it. Okay.
Okay, okay, ma'am.
And if you do have or some topic is left out, just please feel free to message me by Sunday evening at max. Because I think then the session of one of the TAs gets over, and then you can get an idea like what topics are remaining, or if you have still not understood. Okay, so that we can design this lecture accordingly and help you out. Okay.
Okay, sure, ma'am.
Okay.
Okay.
So were all of you able to get what are the values that you are getting for that PCFG example that I gave? Was anybody able to solve it thoroughly, like end to end, or not? Could any one of you please display your screen and show me the solution if you have been able to do? I just wanted to validate whether the code is giving the correct answer or not. Anybody of you would like to share their screen and discuss the solution, what you have been able to derive? So did anybody solve it or not, first of all? Okay, I am not sure whether any of you have solved it, but I would say that this is an important topic and there can be paragraph based questions on this. So please try to, go through it, and I'll share the link of these two code notebooks, and just validate it with your with that matrix formulation that we discussed. The answer given by the code is correct or not. Okay, for both the parse trees that we are getting, we already know that this can result into ambiguous and two parse trees, because different set of rules, with the different set of the rules, you can get to the start symbol. So there are two parse trees possible. Just validate it once. Okay, so that's all for today. So thank you, I would say. And if you do have, okay, good, if you are still in progress, it's good. So do you have any more specific topics that you would want me to cover in the next week? Please feel free to let me know in the chat box. And I hope today's coding session gave you some insights from a different perspective. Okay. Okay, good. I am happy to hear. Okay, then. Thank you. Then we meet same time next week. Thanks for joining. Hoping to see you in the next lecture, all of you. Thank you so much. Please try to solve this example. Yeah, thank you.